Hi, my name's David Wright. I'm the founder of S.p.A Aviation. S.p.A Aviation is working together with GES on a vegetation analysis remote sensing project where we are taking images from the air on a manned aircraft that you can see behind you over onions and lettuce crops during the 2015 growing season. The aircraft I'm using is a Sky Arrow. It sits in the lightest weight class of any commercial aircraft. That's called the Very Light Aircraft, VLA category, which is the lightest class of aircraft you're allowed to work commercially with. The aircraft itself has got a very unusual configuration. You can see it has a high engine and pusher prop. That's very deliberate because a conventional aircraft with the engine at the front and propeller at the front would have exhaust gases going back over the sensor apertures, which are directly in the belly of the aircraft. Those exhaust gases would be seen by the sensors. They would be in the wavelengths that the sensors are looking for and therefore confuse the picture. So it's very important to take the exhaust gases out of the equation by picking a configuration where the engine was high up. The aircraft also has a big wingspan for its weight and is very stable, which allows me to fly in fairly windy and turbulent conditions and still gain accurate data sets. The importance of its weight is that I can fly using very little fuel. So although you might think burning aviation fuel in the overhead of farms is a bit counterintuitive in a green progressive viewpoint, this aircraft is burning less fuel than an average farm vehicle would driving around the crops. And I can cover vast areas. Flight speeds are still high, 180 to 200 kilometers per hour, and I can gather data comfortably over 1,000 hectares per hour, all at very low operating costs in fuel terms. The aircraft, although is very important from a business context, is really a distraction from the main event, which is the quality of the data I gather, because that's the part, of course, which is the focus of the grower. And let's have a look inside to give you an insight as to where this sensor payload is fitted. So we remove the rear seat, and underneath there are two sensor apertures. I have a front one, which you can see being used, and a rear one. And I can carry 45 kilograms of payload, which allows me on a single flight hour to gather 4 or 5 different data sets, which is another way to make it a very viable way to collect the data. And to give you an idea of scale, that allows me to collect data at least 10 times less than the cost of an average drone, because we can fly for so much further, for so much longer, and gather multiple data sets on each flight, which is all reducing that unit cost. Now, the information that we're gathering from the ground is incoming radiation being reflected by the vegetation. And we are collecting that reflected irradiance and we are putting it through various processing tools to work out change detection in effect. So anything that is starting to stress the crop shows up at specific wavelengths. And we are working together, S.p.A and GES, on a project called Magnaghi to understand the spectral changes associated with some key disease conditions.
Hello, my name is Sergio. I work at GES Growers as a remote sensing technologist. I'm involved in the Magnaghi project. My role starts from the second stage of the project, once David has gathered all this aerial imagery, and then he sends all that imagery to our office through our server in the cloud. We then analyze the data that imagery contains using geographical information system and other software. The aim of the Magnaghi project is to generate really valuable applications for the business, based always in end user requirements. Therefore, a good communication between our side and other parts of the business, such as the harvesting teams or crop managers, is really key for this project. One of the main applications that we are generating at Magnaghi is the vegetation index maps, more commonly known as NDVI maps, We use these maps to show differences in performance in our crops by visually showing the differences in photosynthetic plant material present in the crops, and we utilize for that a range of colors from light green to red color related with, so red color would be bad performance of the crop and green color would be good performance of the crop. Once that's done, these outputs are distributed to our end users, like as I said, agronomists, harvesting teams or crop managers through our Growing Innovation portal, so they can download these outputs in different formats such as PDFs or Google Earth files that they can download to the portable devices such as smartphones, iPads, wherever they are in the fields, and they can see straight away that map and the issue on the crop and assess that and feedback to us.